Hi guys, welcome back to my YouTube channel, and today I'll take a CPM part, that is resource allocation problem in project management. I've shown you a PPT of mine in some previous video that how to deal with the project network and how to construct a network with given activities, duration and the sequence of the activities. This was the problem we were discussing in the previous video. These are the activities. You can see the activities A, B, C, D, E, F, G, H, I up to L, and the duration of these activities in days. For activity A, the duration is 3, and the activity B, the duration is 2, and the activity C, the duration is 4, and so on. The immediate processor is, you can see here, immediate processor of A. Immediate processor of A is none, means there is no immediate processor. I'll explain later on what is the meaning of this none. And then the immediate processor of B, the immediate processor activity B for B is A, and for C is A again, and for D is A again, and so on. So I'll explain how to construct. First of all, the fourth column we have resource required operators. Means you can say labor or skilled labor or unskilled labor, or there are different kind of resources we use in project management. So how to manage those resources? So the purpose of this discussion is to reduce the cost and increase profit. Obviously, now let me start how to construct a network. So now I have taken a blank notepad of Samsung writing pad. So I'll explain step by step how to construct a network. It is very easy, but sometimes we have some confusions. So let's see how to construct. Now first of all, just construct an event. Event is a round circle like this, and activity is a straight line arrow line. Okay, so we will construct an event first of all. Now if any activity with no processor, that is A activity, A activity has no processor, so this activity will commence from starting event, because for this event there is no processor. Okay, now again this is activity A. Okay, now after completing this activity, just construct another event, another circle, that is event. So any activity is represented by arrow like this, and at the start of any activity there is a event, a circle, and at the end of any activity there is a circle again. That is this one is a starting event, and this one is end event for activity A. Now take next activity B. So for an activity B, the immediate processor is A. That means the activity should start from that event where activity A has the end, or activity A ended. Activity B will start from that event where activity A ends. Next, activity C, the immediate processor is A. So this activity will also commence from this event, and because immediate processor is A, so C will start where A activity ends. Next, the D activity, for D activity, the immediate processor is A. So here I'll set this. Now again you can see the activity D will start from that event here, this event where activity has the end, or activity A ended. Next, the activity F. Now the immediate processor of activity F is E. So obviously activity F will start here, from this event to this event. We have to construct a circle on both sides of any activity, any arrow means activity and event means circle. Next, the G activity will start where C ends. C ends here. G activity will start from here. So construct. So this is G. Now you can see FHI should ends in a single event. F is this. Okay. So I should end here, and H should end here. That means the second arm, that is J, J, and now the L activity will start from here where FHI ends. Okay, this is L activity. Now again you can see that activity K, there is no successor. There are two activities for which there is no successors. Okay, the L, there is no successor here, and the activity K, there is no successor. That means these activity will end on end event. This is end event, this is starting event. For end event, you can see there are activities which has no successor, ends on last event, and activities for those there is no processor, ends starts from starting event, that is first. Okay, so this was the explanation. I'll explain again. There is A activity here, start from starting event because there is no processor of A activity, none. So it will start. So this is the clue. The activity or network will start from this event, starting event. Now there are three successors of A activity. Means these B, C, and D will commence from this event where A ends. Now, so B will start from here to here, C will start from here to here, and D will start from here to here. And you have to construct circles on both the sides of arrow. An arrow represent activity and circle represent event. Now, for G, activity G, the immediate processor is C. So activity G will start from C, where C ends, and for activity H, the immediate processor is D. So activity H will start from this event where D ends, and then I starts from this event where G ends, and J starts from this event where D ends. You can see in the table, and K starts from this event where J ends, and L start from this event where F, H, and I ends. Here this you can see this event. There are three activities converging to this event from where L activity will start, and L and KL activities will end on this circle. That is this event. This event is end event and last event. Why? Because there is no successor of this two activities, and that's why these two activities will end on the last event. This is the clue. You have to start from that activity for which there is no processor, and you have to end to that event where converging activities for those there is no successor. Now this is the network diagram. Now the next step, how to give numbers. So the next step, immediate next step is to number this network diagram, numbering. So construct, I'll start with, because I have to make explanation according to my previous video, and I have taken in that 0 for this event, 1 for this event. I'm taken straightforward from my PPT because in the previous video I have explained all these things. I have given this event number 3, for this event number 2, for this event number 4, for this event 5, for this event 6, for this event 8, for this event 9, and for this event 7. These are the numbering 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now partition these circles so that we can write down the latest and earliest time. In any circle, here is the number, and here is earliest time of any circle event and latest time of any event. Here is the explanation of this. Earliest time, you can see here earliest time, and this is latest time. Okay, and this is number of that event. Okay, so now after numbering, go in the initial table of given table. You have to write here duration in days for each and every activities. You can see here these are the activities. Now you have to write the duration. For A activity, you can see in the table, A activity, the duration is 3. For B activity, the duration is 2. The C activity, the duration is 4. The D activity, duration is 6. E activity, duration is 3. For F, the duration is 2. G, duration is 6. H, duration of 4. J, here we can write here J. This is J activity. For J activity, the duration is 2. K activity, the duration is 2. For L activity, the duration is 4. And for I activity, the duration is 4 again. Now what we have done, after numbering events, we have to write down the duration of these activities. For activities, there must be duration, there should be duration, because without any duration, there is no activity. And for any event, the duration is 0. That is, now what we have done, we have done numbering for the network and noted down the duration of these activities. You can go to the previous table, previous video, and you can see what I have explained verbally, because it was not possible to explain written explanation in that video, because I was live on that video and नोटपैड उसमें वर्क नहीं कर रहा था, क्योंकि स्टार्ट ही नहीं हो रहा था, पता नहीं कोई टेक्निकल इशू था यूट्यूब से, नोटपैड स्टार्ट नहीं हो रहा था. Now, after this, after numbering and the activity duration, now we have to calculate earliest and latest time of these activities, events or activities. Same. We will write here the earliest time and here latest time. So, what we have to do, we have to write down 0 in this starting event. We will start from 0. So this is the earliest time of this event, and we are going forward from this to and this. Okay. So initially we will take, or assuming this earliest time for this event is 0. Now, if this activity A will start, if the activity A starts on 0 time, then it will end in 3 days, because the duration of this activity is 3. So, starting event, let me explain again. For A activity, the starting event earliest time was 0, we have assumed. You have to add 3, the duration of that activity. You will get earliest finish time of this activity A is 3. Same logic for this activity B. The initial starting time for activity B is 3. Earliest start time for B activity is 3. So what is the finish time? Add duration of that activity in the start time. You will get 5. Okay. Now for activity C, the earliest start is 3 again, and the duration is 4. Add in this 7. Here in this direction for activity D, the earliest start is 3. Add the duration of this activity. You will get 9. Here in this side of each and every circle, we are writing the earliest time. Earliest time. I repeat, earliest time. Earliest time and latest time. Now for this activity E, the starting time is 5. The latest start time, earliest start time is 5. Just add this 3 in 5, you will get 8. So the earliest finish time of this activity E is 8. For this activity G, the starting time is 7, earliest starting time is 7. Add 6, you will get 13. Okay. Now for this activity, the earliest start time is 13. Add the duration of this. Here we will write, I'm not writing here because there are 3 activities converging on this event, so we have to take some logical earliest finish time. So I'm just writing here the earliest finish time of this activity here, 17. Earliest finish time of this activity, 8 plus 2, that is, because 3 activities converging, so we have to consider all these three activities. From this activity time comes 17, from this activity time comes 10, and from this route the activity time comes 9 plus 4, that is 13. Now I'm explaining again. For this event there are three activities or three routes are converging, so we have to take consideration of all these three routes. Means we have to consider all three earliest times. The earliest time is 10, and from this route h the earliest time is 13. So you have to take the maximum amount of these three, all three routes. The maximum amount is 17. Why the maximum duration? Because this activity L cannot start until this event activates or come into existence. This activity L cannot start from until this event or all these three activities finishes. That means we have to take the maximum. Here on 17 days, this all three completed. So in that point, this event will come into existence, and then L can start. This is the meaning of this practically. Here for J activity, earliest start time is 9. The latest add the duration, and you will get the latest earliest finish time. Now for L activity, or from here, again you can see for this event and event 9, there are two converging paths. So you can add from this path 17 plus 4, that is 21, and here 11 plus 2, that is 13. So we have to take a maximum. The same logic, this event cannot come into existence without completing both the path. So this is the maximum time. After 21 days, this event can come into existence. Now what we have done, by forward path, by forward direction, or moving forward, we have calculated earliest time of all the activities and events. Now we will calculate the latest time of all the activities and events by backward pass, moving backward. So you can see for end event this is the earliest time and this is the latest time. For end event, the earliest time is latest time. So what you have to do, write same number here, 21. Okay. For end event, the earliest time is latest time. Okay. Write 21 here in this right hand side. Now go backward in this direction. Okay. For this activity, the latest time 21, the latest finish time. Now we have to calculate the earliest, the latest start time of this activity. Minus 4, 21 minus 4, that is 17. Now for this, the latest finish time is 21. The latest start time will be obviously 21 minus 2, that is 19. Sorry. Now for this route, the latest finish time of I is 17. The latest start time will be 17 minus 4, that is 13. Here for this route F, latest finish time 17 minus 2, 15. The latest finish time is 17. 17 minus 4 is, now here there are two activities starting from this event, so we have to take consideration of both routes. Now from this activity, the start time of this event is, latest start time is 17, and from this activity the latest start time is 13. Now in backward pass or backward, moving backward, we have to take the least time, least. Okay, so we will consider 13. 17 from this route moving backward, and 13 from this route. So we will take 13, the least time, minimum of these two. Now for this G, 13 minus 6, 7. From C, for C, here for this event 1, there are 3 routes moving from this event. So we have to consider all three routes. From this route we will get 3. From this route we will get 15 minus 3, that is 12. And 13 minus 6, that is 12. 13 minus 6, that is 3, then 7. So the least one is 3, so we have to take this one, 3, and the last the last part, 3 minus 3 is 0. Now you can see here this part the earliest time and this part the latest time. Now you can see what we have done. We have numbering all the events and then write down the duration of the activities and then calculated each and every earliest and latest time for each and every activities. Now you can see here, if you'll notice both the time of any event, you can see here for some events there is similarity. You can see 0 0, 3 3, 7 7, 13 13, 17 17 and 21 20. And any other event other than this path, there is no similarity. 5 and 12, the earliest and latest time are dissimilar. Here in this case, earliest and latest time are similar. So this means that this is a critical path. This is known as critical path of this project. You are well aware of the meaning of this critical path. How you can identify the critical path? If there are several things, the floats are 0 for critical path, there is no float. But here, if you want to understand logically, if there are earliest and latest time are similar for any event, then you can write the double line, that is critical path. So here this is the critical path. Is 0 1 3 5 8 9. This is the critical path, and the total duration of project is 21 days. Critical path is 0 1 3 5 8 9, and the total duration of the project is 21 days. So you can see we have done few things. First, we have constructed a network diagram by the help of that table, the predecessor and successor table. Then we have calculated each and everything, earliest and latest time of each activity and events, the same thing. And then the critical path. How to find out the critical path? The critical path, the earliest and latest time of any event. In the critical path, earliest and latest time of any event or each event is same. So you can identify the critical path by this. The logic is the total float for this path is 0. So for each activity in this path is 0. So I'll end this video at this moment because it will go beyond 1 hour. Now further discussion of time scale diagram and resource allocation for which we have taken this video, I will discuss later on in the next part. So I'll end this. Thank you.